Hello everyone and welcome to Data by Design. To continue our discovery of the concepts related to OLAP, we will now look at the concept of the aggregation of indicators. To do this, we'll use a new modeling example, one that simplistically describes the sales of a supermarket. The amount of purchases can be aggregated by department and then by store. They can also be aggregated according to time indicators. The unit data could look something like this. Yes, I asked ChatGPT for help. It's almost a detail, but we see how to aggregate the data by department. For example, it is already necessary to isolate the lines of each department. To simplify the aggregation, I asked ChatGPT to sort the data by store and by department. For those interested, data transformation tools that work line by line will often require you to sort before aggregating the data for memory optimization reasons, as we are doing here. We will now be able to start the data aggregation. Today we are going to start with a sum calculation, which is probably the simplest calculation that we can do. We will perform our aggregation stage by stage. First, by calculating the amounts by department and then by store. As you can see, this is quite easy. We could of course do the same exercise by summing over the date and the month. Thanks to the few very simple rules that we have mentioned, we are now able to obtain the values of our indicators according to all the contexts allowed by our model. Let's now move on to the pitfalls to avoid at the modeling level that have an impact on aggregations. I will present here a classic problem of aggregations on the time axis. Say you want to create 2 reports, one per week and one per month. You decide to implement the following model. A priori, this model respects all the rules that we have stated so far. Nevertheless, let's do the exercise of summing the information, first by month and year, and then by week and year. To simplify, imagine that the amount is $1 per day for the year 2018. For the month, we will aggregate the following data, which give us the following results. And for weeks, we will aggregate the following data, and then we realize the sums per week. Let's display the two results side by side. So far, everything seems consistent, but the problem arises when we try to sum the amount columns in the two tables. So, where does the error come from? If we take a closer look at the basic data, we quickly see where the problem comes from. We have a discrepancy because the weeks straddle the calendar years. We have shown here two notions that were initially the same, but which in fact have different meanings. It is therefore advisable to dissociate the years associated with the weeks from the calendar years. This method is generally called ISO week numbering year. So when modeling hierarchies, I advise you to avoid loops that create confusion and which can be a source of error during the creation of your reports. We won't go any further in this video, but next time we'll stay on the subject of time hierarchies and talk about semi-additive measures. As always, if you liked this video, please consider subscribing and liking. See you soon. Bye!